Here we are with some other big items that go beyond 1 million tons in their carbon footprint. And a volcano shows up here. 1 million ton CO2 equivalent when Mount Etna is puffing and huffing and puffing in a quiet year. 42 million ton CO2 equivalent when Mount Pinatubo erupted in 1991, one of the big eruptions in recent history. There is often confusion created by climate deniers or vested interests saying volcanoes emit more carbon dioxide than humans, and there is lots of literature to show this is just a complete bogus claim. Volcanoes obviously emit a smorgasbord of chemicals that are of relevance for radiation balance. So some of them can cause cooling, some of them can cause warming. So you have sulfur dioxide, carbon dioxide, hydrofluorines, whatever that is, hydrochloric acid and ash. So you have photochemistry with OH, albedo changes, ozone destruction reactions happening. Sulfuric acid is being produced by the combination of or dissolution of CO2 into the water that's available. Acid rain is always something associated with volcanic eruptions. There is condensation, coagulation, sedimentation, circulation effects, cirrus clouds, nucleation, and so on. I have a detailed coverage of volcanic impacts on circulation, global temperature, droughts, and other things in the geoengineering course, but this is here just to show. This figure from Carbon Brief, but originally made by NASA GISS, I think, Goddard Institute for Space Studies, shows that when you take composite of volcanic eruptions, you always look at temperatures few years before eruptions and few years after eruptions, because each volcano cannot easily be quantified for its impacts. But when you take multiple volcanoes, then you get a better handle on exactly what the volcanoes do. Despite all the CO2 included in the eruptions, the main impact turns out to be a global cooling. So you can see there is some variability before the eruptions, typically for all volcanoes, which has interannual variabilities in the global mean. After the eruption, the cooling starts and it persists for several years, depending on how massive the volcanic eruption is, and then you get back to natural variability again after a few years. So this is robust science, has been modeled, has been understood, observed very well, and so on. If you look at specific estimated numbers, yearly CO2 emitters, global volcanic emissions with the highest preferred estimate in terms of billion metric tons per year is at 0.26. Anthropogenic CO2 from fuel combustion in 2015 is at 32.3 gigaton per year. So this doesn't even include land use change contributions, cement and other things. So let's not even pretend that volcanoes come anywhere close. Worldwide transportation in 2015 was at 5.8 gigaton CO2, and approximately 10,000 megawatt coal-fired power stations emit 0.22 billion gigatons per year. They are competing with volcanoes here, and they have a lot of particulate matter as well. Argentina emitted 0.19, Poland 0.28, and United States 4.99. So this is just to show you that the information that you get from some quarters that volcanic emissions are comparable to human emissions is just not a valid claim. CO2 emissions from individual events: Mount St. Helens in 1980, 0.01 gigaton. Mount Pinatubo on 15 June 1991 was at 0.05 gigaton, so 5 times, and that's one of the big eruptions in recent times. Number of Pinatubo equivalent eruptions equal to 2010 global anthropogenic CO2 is 700. So 700 Pinatubo eruptions would amount to human emissions of one particular year, 2010. Number of Mount St. Helens equivalent eruptions equal to 2010 global anthropogenic CO2 is 3,500. Okay, so here is a nice graphic showing various volcanic eruptions in the volume of ash and stuff put out. Mount St. Helens, Vesuvius, which remains a historic event, was at 1 cubic mile, Pinatubo at 1.2 cubic miles, Krakatoa, which created lots of problems in 1883, was at 2.2 cubic miles. Nova Rupta in 1912 was 3 cubic miles, one of the biggest ones recently, and there are a bunch of smaller ones here. One in Iceland in the 1990s created a lot of flight shutdowns, and a lot of good data exists from that volcano as well, but it wasn't very big. To give another context, if you look at the rise in atmospheric CO2 causing climate change, the global carbon cycle from 2008 to 2017 in terms of the various components, anthropogenic fluxes given by these gray arrows, so 34 gigaton CO2, carbon cycling per year, so these are thinner arrows, and stocks available are shown here as reservoirs as well. So big numbers here: land use change contributing, biosphere taking up, vegetation storing permafrost soils, atmospheric increase during this period plus 17.3 gigaton CO2. Ocean took up 9. You can see the fluxes in and out of the ocean and land. Obviously big numbers with small differences which correspond to sources and sinks, so we have to be very careful. There are reservoirs in all these various things, including oil, coal and gas reserves, dissolved inorganic carbon in the ocean and marine biota. So there is an imbalance of plus 2 gigaton CO2. But the main point we want to look at here is that with all these big numbers being involved in anthropogenic emissions and other natural reservoirs and so on, volcanic emissions over this period was only 0.5 gigaton CO2. Okay, so this per year. We have to be very careful when we look at claims that are just patently false. Okay, so volcanic emissions have big news value when they erupt, obviously, and scare people and give visuals of massive emissions, but overall per year they are tiny compared to what humans emit. The other item here, World Cup, 2.8 million ton CO2 equivalent for the 2010 South Africa World Cup. That's 6,000 space shuttle flights, 3 quiet years for Mount Etna, or 3.5 cheeseburgers for every man, woman and child in North America. How do you compare these for social and cultural values? This is something we have to talk about. But first, the carbon footprint of the 2010 South Africa World Cup was made up of international transport for the players, international transport for the spectators, energy used in the accommodation of the spectators and players, stadia and precinct energy use, stadia construction and material, embedded carbon, other transportation involved for everyone else. Billions of people watch it on TV. They don't travel to the site. Tickets are super expensive. So how do you compute the carbon footprint per person? If you divide by the total number of spectators, it's going to be tiny. And the cultural value, the world's attention on soccer, football World Cup is massive. It's all kinds of entertainment value, cultural value, social value. So obviously just carbon footprinting is not going to be a good way to do it. Nonetheless, knowing these numbers allows us to reduce carbon footprints. For example, the Middle East would do it with all solar energy according to what is being proposed. I think maybe that's the next one in UAE or somewhere. So obviously there is room to reduce carbon footprint, but we also have to remember the externalities in terms of what value such events bring in terms of people's participation, people's interest, people's love for the game, national identities, international competition, all those things matter. Of course, there's a lot of employment involved, there's a lot of economic value involved, consumption involved as well, flying around involved, but overall, one would never advocate shutting down World Cup, but there is plenty of room to reduce the carbon footprint. Okay, we'll come back and look at a couple of other items, the big ticket item in this range being the data centers. Okay, see you in a minute.